All right, is it about time? Are we on or? Oh, okay. Let me.
Let you know when it's
This riser rumbles a little bit. It's a little bit freaky. Okay, everyone. Thanks for coming to my talk here. My name is Doug Stevenson. I am I could do that. My voice sounds loud from up here. Is this oh, okay, now I'm live. All right. Thanks for being here. My name is Doug Stevenson. I'm a developer advocate with the Firebase team at Google. First thing I want to say is I love this time of year, late April, because I'm actually a really big hockey fan, and that means every day there's like 4 playoff games for the first round of the playoffs, so I'm super excited about that. I'm actually pulling for the Hawks today because I think the series would be ended very prematurely if they do not win today. And I know I've seen at least one of you wearing a jersey, so I know there's one other Blackhawks fan. I'll be watching the game after the show, so definitely pulling for the home team. I am here to tell you about what's new in Firebase. Now, most of you have probably heard about Firebase. We announced this at Google I/O 2016, just a year ago. So it's as a platform, as a unified mobile development platform. It is just 1 year old. Now, it's actually 5 years old. Like the original Firebase backend as a service has also celebrated its 5-year anniversary, which is super exciting. The current offering we have now for Android, iOS, and the web. So Android and iOS are actually first-class citizens in the Firebase world. We support the web where it makes sense. Web support is getting better. But the first new thing I'd like to say today is we actually just released Unity and C++ SDKs for Android. So we take game developers actually very seriously. We heard a lot of feedback from game developers saying, you've got some great tools, but I do everything in Unity. I'm not going to write Java code. I'm not going to write Objective-C. I need to do it all in Unity. So we have SDKs now that will call that essentially wrappers around those. So that's look for that. We're doing more video tutorials and more documentation for that. So if you're a game developer, please check that out and send us your feedback. The original component, Firebase Real-Time Database, the thing that's 5 years old, you probably all know this already. It's the same database that you probably already know and love. For those of you who aren't familiar with it, it's actually a real-time database. It's a NoSQL database, meaning when clients write into Firebase Real-Time Database, that data is I'll say instantaneously, as fast as your network connection can handle it, distribute to other clients who are also listening. So if you write into a location at the database, all the other clients listening to that location can get real-time updates. Now, this is pretty valuable, right? This makes for some fairly unique style applications. So the one that you see people talk about all the time is like chat apps, right? You write your message into the database, and then everyone else is essentially receiving that message in real time. Now, the things that are new in here, there's not that much, but it's the improvements that we've seen lately are around scalability. So we used to have a 10,000 concurrent connection limit to one given database. The reason why we had that is because if you were going to go over it, we wanted you to call us and say, let's do an audit of your app. Are you doing things properly? Are your queries indexed? Are you, pulling down the right amount of data per client? If you were not doing things very well, we would kind of give you a hint and say, if you really want to scale, you're going to have to make some changes to your app. But now we're actually very confident in our ability to scale even bigger than we have been. So the default limit is now up to 100,000 concurrent connections. We'll do that for you without an audit. To further help performance, there's now a profiling tool. So in the command line, you can do I can't remember what it's called, Firebase profile. And you can actually look at the response times for queries that are coming into your database. So during development, you can find out when your app is running, is it sane? Am I obviously doing anything good or bad? Now this is a pretty big win because a lot of people didn't really have an idea of what the performance of their app was like. They would just ship it, and then they would, something would be terribly wrong inside their app. They would notice bad performance and then have a bad impression of Firebase, which we did not want. So we're more interested in giving people the tools that they need to discover the performance problems in their app and be able to remedy that with better design. Now, the other thing that's improved greatly, I would say probably the most improved component is Firebase Analytics. So those of you coming from the other talk, you probably just got an earful about how you can use analytics to understand your user behavior in your app. The feedback that we received on that was unanimously in favor of being more real-timey, just like real-time database. So real-time database, you get used to things happening instantly, and if your analytics are also not happening instantly, it doesn't feel right as far as the platform is concerned. So when we launched analytics, it was something like a 4 to 6 hour delay when an event would happen in your app to the moment you would see it in your dashboard. That just makes it difficult to find out, you have this delayed view of your app, and it makes it hard to test and debug. So there's two new things that got added to it. The first is Stream View, and the other is Debug View, and I'll say a little bit about both of those. These were both launched in November at the Firebase Dev Summit. So Stream View looks kind of like this. It gives you a map. This is just showing the United States, but you get a map of the world, and you have these little hotspots of where your users are actually using your app. You get some sort of basic statistics to see what's going on. So this gives you, and by the way, this is live. If you leave this page on in your app while it's running, it will dynamically update, and you'll get to see real time. Now, don't get me wrong, this isn't some creepy God view where you can spy on your users. All of the data has been fully anonymized, so everything you're seeing is fully anonymous. All you're seeing is location, and you'll get to see some individual event streams. But there's no way of really identifying anyone. But it does give you a very clear look at where users are using your app. Now you can see a little button down there called User Snapshot. If you click that, you'll get a random user series of events. So if you've coded your app up to send events and you want to know how people are actually using it, you can watch in and see, this is an example of a game. This is Flood It, which is our demo app. You can see how users are actually playing the game. So when they start a level, how do they select the level? How long are they spending in the level? It's actually very interesting information to know. Now, Debug View looks a lot like this, and Nitya mentioned this before. In Debug View, you can dedicate a development device right in front of you, and if you've coded it up to send events, you can see what those events are in real time. This was a big problem for developers before, because you would code up your app to do events, and then you would run your app, and then you would get no feedback. And then you'd come back to the dashboard 4 to 6 hours later, and then if it wasn't right, you wouldn't really have a sense of what did I do wrong? What do I have to change? Here you're getting instant real-time feedback about how your app is actually sending events. So it's actually a lot easier to develop and come up with a sane and sometimes complex stream of events and make sure and have confidence that it's working correctly. And the other thing that's improved is real-time export to BigQuery. So for those of you who know, Firebase Analytics is free. Any app can use it. It's essentially unlimited. But for cases where you need to dive deeper into the data and do diagnostics and analysis on it, you need to export that to BigQuery, and that's a paid feature. And again, the export was on a delay, so you could only do processing on data that was a little bit older than you want. Now that there's real-time export to BigQuery, you can actually look at a table that gets populated with events in near real time. So now you can do real-time processing of those events if you have apps that are connected to BigQuery. Crash reporting received a lot of improvements. This actually launched in beta at I/O 2016, and then in November at the Firebase Dev Summit, it exited beta with a bunch of new features. So again, real-time databases, real-time. People want more real-time stuff. Crash reporting, when it launched, had 20-minute delays on the crashes from the moment they happened in the app to when you can see them in the console. We dropped that down to less than 1 minute. So this is now super handy, right? If something happens, you can know a lot faster and get fairly instant feedback. The other great thing is it got integrated closer to analytics. So if your app is generating analytics events, those will appear as breadcrumbs in your crash log. So if there's a crash, you can know the things without writing any lines of code. You can know the things that the user was doing in the app just before the crash. Now that extra context is very valuable. You want as much information as possible when you're trying to diagnose a crash report. Just a stack trace sometimes isn't good enough. You want to know how the user got to where they are. And the other super handy thing is email alerts. So every night we'll email you a digest of new crashes that have been seen in your project. So it gives you a nice to-do list of things to do the next day if you didn't already have enough things to do in your day. Firebase Test Lab for Android saw some improvements as well. Now, as implied in the name, this is Firebase Test Lab for Android. This is the one point in Firebase where iOS and Android are not equal. There's no Firebase Test Lab for iOS. It's just Android right now. So the good thing we're at an Android conference because you're probably more interested in this than most developers. By the way, who is into testing their apps? Does anyone? Oh, more people. Okay, good. Usually it's like one dude in the back who's like, it's me. And I'm like, yeah, you alone. It's too bad. Actually, I'm fairly into testing apps as well. It's traditionally been not very easy to do. But Firebase Test Lab is essentially a cloud of devices. So, you think of servers in the cloud, right? You have racks and racks of servers, and you don't really know about them. You don't even know where they live. They're just out there, and you use them. It's the same way with Firebase Test Lab. With Firebase Test Lab, you have racks and racks of actual mobile devices, and in some cases, virtual devices. And when you run your tests, you're actually deploying to those. So you don't have to own them or maintain them or manage them. The way that Firebase Test Lab has improved, and the way it's always improving, to be honest, is we added more device types. So I think Firebase Test Lab launched with 20 distinct real physical devices. That's up to 30 now. We also added more virtual devices. So, and also newer versions of Android are available in pre-release. So I think, I don't know if we offer it right now, but we plan on offering Android O on virtual devices ahead of the release of Android O. So you can test on it and actually know if your app is going to run on O or not. That would be a nice thing to know because you don't want this new device to come out and then have no clue if it's going to work for your users. Now, there's one interesting thing, it's interesting to me. I don't know if it's interesting to you. But the team discovered that one of the biggest problems with maintaining a test lab is actually just getting a hold of the devices. This has to be at scale. We need thousands and thousands of devices to support thousands and thousands of developers who are running on those. It's actually really, really hard to get hundreds of devices. We buy them in bulk, right? And that's actually kind of hard, especially order devices. You end up going to eBay and buying a bulk, collection of these really old devices. So that's one challenge that's been discovered in terms of scaling. But we're definitely keen to work that out. Now, one thing that's really unique to Test Lab is a special test called a robo test. So those of you who raised your hands and you do testing on your app, you probably write Espresso or UI Automate or instrumentation tests. And those are really handy. They take a lot of time to write. They take a lot of time to define. And you have to make sure that your tests are not flaky. You have to go through that kind of trouble. With Robo, this is a fully automated test. So Robo actually looks at the UI of your app and finds buttons to push, and it basically tries to crawl your app in the same way that Google would try to crawl a website. Now, this is great. A lot of developers use this, but Robo had a pretty significant problem when it first launched. It didn't know how to pass a login screen. So if you had a login screen with username, password, and that, it wouldn't know how to deal with those text views. You would see them, and it would maybe interact with them, but it didn't know what to type to actually log in. So the big improvement to Test Lab is, that's not the one. The big improvement to Test Lab is that now when you run a robo test, you can provide key value pairs for text field or text views edit text that you want to populate. So if you know the Android resource ID of an edit text, you can give it some text to fill in. So now it can bypass login screens. Now it can perform searches in your app. Now it can do anything where input is required to actually progress in your app. So now you have a deeper and broader scan of your app. And again, you're not writing any code. It's all configuration. Now, maybe the biggest improvement to Test Lab is the fact that it's now free. Well, I would say free with limits on the Spark plan. So if you know in Firebase, there's 3 payment plans. There's Spark, Flame, and Blaze. And Blaze was the option you had to be on if you wanted to use Test Lab before. With that, you're paying something like $5 an hour for devices and $1 an hour for virtual devices. On the Spark plan, where there's no credit card and no billing whatsoever, now you have a daily limit of something like, I think it's like 10 tests on real devices and 5 tests daily on virtual devices. So now you kind of don't even have an excuse. Like, you should be able to audit this thing or like try it out and even like maybe integrated it into your CI, right? So nightly you could run a battery of tests. This is huge for adoption of the product because a lot of people, once you ask them for a credit card, they're lost, right? I'm like that too. I never put my credit card into anything. So just trying out Test Lab was a problem, and now it shouldn't be a problem for anyone. Another Firebase feature that got a fairly significant update was app indexing. So the way we launched app indexing is basically a way for your website and your mobile site to essentially share context, right? So if you had, say, an e-commerce site and you had all these items for sale, and you also had an Android or iOS app with the same items for sale, you could link the content between the two. So a search on the website could essentially promote your mobile content. So in a Google search, you would say, oh, I recognize you have a mobile app, click here for the mobile version. So you could funnel traffic into your mobile app, which is theoretically better than your web app, if you even have a web app. That's good. We can make that better, and especially on Android. Again, this is an Android conference, so I expect Android developers to be more interested in this. With app indexing, now you can index personal content or user-directed content. So if the user is chatting inside your app, you can index every single message. If the user is looking through your e-commerce app and shopping for shoes, you can have a record of every item and know that they're very interested in shoes and have that index. Now, that index doesn't do anything until they come back to the Google search app within your device. And the moment they start doing a search in there, it's also actually indexing into their personal content. So if they type shoes, now they'll see a list of all of the things that had the keyword shoes within your app. So they can get right back into your app super fast, seamlessly from the Google search app. So Firebase storage is another feature. This is basically cloud storage. You can upload files, download files. It's great for personal content. So if you have, if you're uploading your users' photos, this is the place where you want to put it. Now, this actually got a rebrand recently at Cloud Next. So instead of Firebase storage, we're now positioning it as cloud storage for Firebase. This just underscores the fact that Firebase storage was always built on cloud storage. So if you're familiar with Google Cloud Platform, it's just built on top of that. And that puts Firebase closer to Google Cloud Platform. Now, you may already kind of know this. If you created a Firebase project, you know that you also are creating a project in Google Cloud Platform. They're the same thing. They're both the same project. It's just Firebase has a view of Firebase features and Cloud has a view of Cloud features. But it turns out the storage bucket between them is the same. But it's not just one storage bucket anymore. You can now do multiple buckets per project. So you can have, if one bucket wasn't enough for you, now in one bucket you can store exabytes of data. So I don't know, is one bucket enough for any app? Well, it should be. But sometimes it's nice to organize into multiple buckets. So you can do that. But maybe more importantly is you can choose the location of the storage bucket. Now, this is big because a lot of companies have restrictions on where they can store their data. So data privacy is very important. If you're familiar with HIPAA, or I know in Germany, user privacy is very important. And so they try to keep users' data within country boundaries. So now you have a better chance of being able to do that by choosing the location of your storage bucket. You can also choose the storage class of the bucket. So you can have there's 4 different classes, and I forget what they're called, but they range from hot to cold. And hot data is redundant and massively available, and colder data is, slower to access, not as redundant, has sort of a lower, a lower reliability, but it's good for archiving data for the long term. So now within your Firebase app, you can manage multiple buckets with multiple classes. Oh, and it's worth noting, hot data costs more than cold data. I just mentioned there's hot and cold. Why would I choose cold over hot? Well, it's a lot cheaper, obviously. Improvements were made to Firebase hosting. If you're an Android developer, you probably don't care about hosting that much. Your app is your hosting. You're not building a web app. You're building an Android app. But maybe your Android app has some assets that are hosted by hosting. If you are interested in hosting, you should know that it's production-grade web hosting for static assets. And the way this has improved since launch last year was HTTP2 support. So this morning, if you went to the first session, you probably got an earful about HTTP2. And now Firebase hosting does support that. It supports multiple domains pointing to one site. So if you're trying to squat all of the domains for your company and all the combinations and permutations, you can now point those all to a single site very easily. Now, one of the great features of Firebase hosting is that we'll actually provision an SSL certificate for you, which is both time-consuming and costly normally. This happens for free in Firebase hosting, and now we've reduced the time a lot more. So the moment you create a Firebase project and start deploying your hosting site to it, the SSL turnaround on that is going to be a lot faster. And there's another subtle feature. If you're not a web developer, this probably doesn't matter to you, but now you can automatically configure your Firebase web app from within hosting. So there's special script includes where you can pull in a pre-configured, basically you don't write any lines of code to get your Firebase project active in hosting. Okay, so that's all the features. Now, there were other improvements. These are the big ones that I think are sort of announcement-worthy, worth mentioning here. There's something that's not a feature, but a tool that a lot of developers use, and that's the Firebase Admin SDK. We originally shipped this in November for Node.js and Java. It wasn't until just last month we added Python. So if you're writing an app, and let's face it, writing an Android app is, it's great to do it on the client, but fact of the matter is you probably do need some back-end service for that. Firebase Admin SDK is the thing that you use to write some of that back-end logic. So some of the things you can do with the Admin SDK are read and write real-time database, obviously for data processing. You can mint custom tokens, so if you need to bridge an authentication provider. So Firebase Authentication gives you Facebook, Twitter, GitHub, Google+, email and password authentication. If that's not good enough, if you need to bridge to some other authentication provider that you control, you can mint custom tokens now and basically authenticate your Firebase users into that other authentication system. You can also manage authenticated users. This is a feature only of the Node.js SDK right now. Basically programmatically create, update, remove users. You can also send push data using Firebase Cloud Messaging. So on your back end, if something changes in your database, you might want to respond and send a push notification to users' devices. Now this is great. Now since this is an Android conference, probably people are not very interested in doing server-side stuff. I know that for a while I was doing full stack stuff, and then I moved for a while strongly into Android. I didn't want to do any backend stuff at all. I liked Android a lot. So my attitude was that I don't want to manage my own server. I don't want to worry about scaling it. I don't want to worry about provisioning instances. I don't want to worry about all that stuff. I want to focus on the experience in my Android app. That's my full-time desire. So the thing is, if you don't have a backend, like I said, you probably don't have a very rich app. A 100% client-side app, there are limits to what you can do. So we've recognized this, and we've heard a lot of feedback from developers, and what they want is a way to have a backend without managing the backend, and that's exactly what Firebase Cloud Functions for Firebase does. So this is maybe the #1 requested feature, and it came in the form of feature requests that say, I want to write some code that responds to a change in my database, right? It's something logically you want to do. You want to be able to respond and know when users are adding things to your database, but you don't necessarily know what form that takes. So this is actually our Google's serverless compute. So if you know the word serverless is basically saying, I want to do backend stuff, but I don't want to manage server instances. I know there's servers out there. I'm not fooled. There's always going to be servers. I just don't want to manage them. I don't want to touch them. I don't even want to think about them. So that's what Cloud Functions provides, a way to deploy code that gets managed by the Google Cloud, and you never have to worry about it after deployment. Now this actually is kind of the glue that brings together other Firebase features. So the reason why I call it the glue is because you can respond to events from different parts of your system and then turn around and write back into that part, or write into another part. The possibilities for what you can do with this are actually vast, and we shipped sample code along with this last month. We had like 30 samples that we think people were very interested in. So I'll go over some of the different things you can do. So you can write database triggers. And what this does, it lets you respond to writes to your database. That was the main feature that I mentioned before. So there's some things you can do like check and sanitize user inputs. So, take the chat app, for example. If users are entering their own stuff and you're worried about, abuse from, people to other people, now you can have a function trigger. Whenever a write happens, you can look at that text, scan it for inappropriate content, and then rewrite the text. You can just change it or reject it altogether. You could also notify users with new data. So again, take the chat example again. If a new message comes in and the user's not in the app at the moment, you maybe want to send them a message, an FCM message. So you can pretty easily turn around and send that message whenever a write happens to your database. In addition to database triggers, there's storage triggers. So I mentioned before there's cloud storage for Firebase. So if you have a bucket attached to your Firebase project, you can now write code that responds to when files are uploaded, modified, or deleted. The very, very common use cases for this are resizing and converting images. So if you imagine an app where users can upload a profile picture and you want to be able to use that, attach that on their profile page. Users are probably not going to upload a thumbnail appropriate size version. They're probably going to want to upload the full size version. And then you want to maybe truncate that down, right? So now what you can do is write some code that when a user uploads something to their storage bucket, you can make it a square, cut it, maybe even find the face, center on the face, then write that back out to the storage bucket. And then you can use that in your app, save your users some data so they don't have to download the full version. You could also detect inappropriate content. So again, with the chat app, if you can share images through that, you might want to make use of something like Google Cloud Vision API. So Google Cloud Vision APIs let you can hand it off an image and it'll tell you what's in the image, right? And you can basically respond and say, well, if that image doesn't contain stuff that's appropriate for my users, you can then do something to make sure that that's handled correctly. You could even extract text from that, right? So there's Vision APIs that let you pull text out of an image, and then you could use that to populate the database. Along with storage triggers, we have authentication triggers. So with authentication triggers, you're basically responding to when new accounts are signed up or when an account is deleted. This is handy for doing things like sending a welcome email. So if someone's gone through the trouble of authenticating with your app and turning over, I won't say their identity, but at least their name and email address and profile picture, you could send them a welcome email and say, hey, thanks for signing up. We really appreciate it. Hope you enjoy using the app. Here's some features. Much more personalized experience. On the flip side of that, if someone deletes their account, what you can do is clean up their storage. So if they had uploaded a ton of stuff to storage and are occupying all kinds of space in your database, now you can respond to that and clean that up so you're not paying for it anymore. And the other kind of trigger you can write, well, there's one more after this, but and Nitya mentioned this a little bit before, you can respond to analytics event triggers. So what you're doing is writing code that respond to conversion events. Now, not every event is a conversion event. Conversion events are special. They indicate high-value users or users who are perhaps your heavy users. So say someone buys something in your app, an in-app purchase. That's a pretty significant thing, right? Someone's gone through the trouble of giving you money or sending money through your app. You could send them a coupon code and say, hey, thanks for purchase. Here's $2 off your next thing. You want to get those high-value users back into your app, contributing more of their value to your app. You could also respond to an app upgrade. So if someone's gone through the trouble of downloading a new version of your app and it has all kinds of new features in it, you can detect that through a conversion event and then say, hey, thanks for updating. Did you know version 3 of my app has this, that, and the other, great new features. Be sure to try them out and send us feedback. So you can know when people are doing things of value in your app and respond to them. There is one other kind of trigger that's a pub sub-trigger. I'm not going to talk about that because that's mostly of interest to sort of hardcore backend engineers. But the last kind of trigger you can write is an HTTP trigger. So this is just basically creating a web endpoint. The common things are creating a public API. So you could create a REST-like API for third parties to consume your data. The more creative uses are things like webhooks. So, with Slack, you can write Slack bots, right? So things that are looking at messages within your Slack and then contributing messages back to that. You can do that with a webhook. This is something that lots of people have wanted to do, create payment processors. So Firebase is great, but if you can't get people to pay you to use it, like if you're selling things, you need to integrate with a payment processor. So we have sample code for integrating with Stripe, and I think you could probably do Braintree as well. All you're doing is basically writing webhooks so that you can interact with them and commit the purchase. And there's one, actually, I've been interested in this one, creating a chatbot. So if you're using something like API.ai, you can define a sort of conversational context for users using an app through a chat interface. Again, to fulfill those chat requests with API.ai, you just write a webhook. And that's really easy. You're just consuming JSON and sending JSON back. It's actually really, really easy. And this is something that I've been working on, and I have some projects in process. And I would love to see what other people come up with. Okay, let's do a demo of a database trigger. I think you say how fun these things are without showing what it looks like, and it's not as interesting. So I have a function deployed to this project. I'm going to make this a little bit bigger. I have an area here called shouting match. What this does, imagine you have a client that pushes objects into the database. So I'm just going to create a fake push ID, give it a quip of, let's see, yabba-dabba do, and I'm going to add that. And so what I do is I have a function sitting back there that looks for new things and enhances the line by uppercasing it and putting a bunch of exclamation points. No one stopped me to say that there's nothing going on the screen. Oh, that was a great demo. Hey, how about that? There we go. So there it is. But now let's do another one where you can actually see it change. So I'm going to do another one. 3. How about fool? Oh, wait. That's not right. So when I add this, I expect the function to kick in and rewrite to the database. I'll do another one just for fun. Oh, I put it in the wrong way. I'm going to start over. This is just gratuitous now. All right, so you can see this is a pretty trite example, right? No one's going to write an app that uppercases everything and then adds exclamation points. You probably want to do the opposite, right? You probably want to take an all caps message and shorten it down a bit and remove the excessive exclamation points. But you kind of get the idea that there's code running back here that is running in response to my event. So I'll actually show you what that looks like. So Cloud Functions is all JavaScript and TypeScript, because TypeScript compiles down to JavaScript. So if you don't know, let me see if I can make this bigger. If you don't know JavaScript, now might be a good time to learn, because this is the only language we support right now. We do want to support more languages in the future, and I don't have any news about that. We're still sort of evaluating what that looks like. But all we're doing here is we pull in the SDK, so Firebase Functions, and then we're exporting a method called enhance. And then we're using the Functions API to create a database trigger that looks at references underneath shouting match with some wildcard push IDs. So those curly braces mean anything. It's a wildcard. And if you know push IDs in a real-time database, it's some string that looks like it's random. Now we're triggering on write events that get delivered an event. And this is, by the way, in case if you've ever done JavaScript, this is ECMAScript 6, which is far better. So I actually used to do a lot of web stuff, and I hated JavaScript with a passion. Thought it was a terrible language. ECMAScript 6 actually works over a lot of those rough edges, and you can do TypeScript if you want as well. So we're going to pull the data out of the event, and we're going to say if the data exists and it has a child called quip that has changed, I'm going to pull the object out of that. So this is a JSON object now, and I'm going to update that same reference where it came from to the uppercased version of the quip and add the exclamation point. So it's pretty straightforward. If you've written, this is actually using, or you can use the Firebase admin SDK with this. So you can do another require here and pull in the admin SDK. So now you have the full power of the Firebase Node.js admin SDK available to you in functions. So now you can turn around and do things like, manage users, send Firebase Cloud messages. You can already manipulate the data here, as you can see, but you can use the admin SDK SDK for that as well. So I don't know. I've been having a lot of fun doing this. I'm actually in the middle of doing something special for a presentation at I/O, so I'm pretty excited about that. But the applications, I think, are nearly endless. So let's go back into here. Okay, so one of the things I thought about when I was first sort of getting acquainted with Cloud Functions for Firebase is that you can use it to fairly drastically re-architect your app. Now, again, this is an Android conference, and I'm a longtime Android developer. And I'm sure most of you are aware of what happens in Android when you have a reorientation and then which is called a configuration change, and your activity completely gets destroyed and you have a new activity coming in its place. And then if there was something going on in the first version of the activity, you have to somehow retain that for the second version. And so you're probably familiar with the problem where you have an Android app that's making a call to an HTTP server. There's a request response going on there, and you have a reorientation. And then what? Like, what do you do with that connection? How do you retain that connection? Or maybe it doesn't matter. Maybe it's just like a quick read, and you don't mind duplicating it again for the next version of the activity, which is not great. But it's worse if it's a write. So if you have a write over an HTTP endpoint, and that gets interrupted with an orientation change, well, how do you recover from that? You don't want to write a second time. You just want to write the first time. You have no idea, did the first one complete or not? You lost its context. Maybe you have some, maybe you're using like a loader or a headless fragment, or maybe you're doing something special with like RxJava to do this. Like, you can't not think about it. You always have to think about it. It's one of the pains of Android development. Cloud Functions actually has the potential to simplify this drastically. Again, if your backend is on Cloud Functions and not on some other backend. So imagine a situation where you have an app that has users, and users write posts. So this is a very abbreviated version of this database. So imagine that a post can have likes, and users can tally up all their likes for all of their posts. So instead of like having to go to all of a user's posts and add up all their likes, we're just maintaining two different tallies. Now, this database structure is common. It makes sense. But the onus is on the client here to upload or to update likes and total likes correctly and atomically. And if you leave that up to the client, you don't always know if that's going to work, right? Because if you have to do two of these things, and you have to do them in sequence and keep them consistent, what if something happens to the client in the middle? What if it updates likes but not total likes? Now you have some inconsistency in the data. It's just rife with problems, and it's a lot of management. So in your Android app, and this is for any platform really, but imagine instead of clients updating these values directly, you had a commands area. And in that commands area, what you can do is have a space for, you have an organization for user ID, and in that user ID you have a push ID, and now you can push commands up into the database through this part, through this structure. Now, it's not even really a database. It's almost like a command queue. You're using the database as a way to funnel commands into Cloud Functions. So a client will push data up in there. It will contain sort of the instructions for the command. And then what happens is Cloud Functions will trigger, right? You can have a function trigger in response to something being added right there. Now, it's not really the client's responsibility to commit that right. It's Cloud Functions' responsibility. So it can turn around, update posts, update users, and then it can send a response back to the client. Now, how does the client get a hold of that? Well, there's sort of an agreement between Cloud Functions and the client that says, when I'm done with something, I'm going to write it to /responses, /whatever the user ID is, /whatever the push ID that the client generated. And because there's that agreement, the client knows where to look for the results. It can be listening there all the time, just waiting for that result. So there's a hidden benefit in this, and this looks like kind of a crazy diagram, but there's a hidden benefit here. Since the Firebase SDK manages the connection to the database in a WebSocket that you never have to worry about, knowing if it's online or online, the client just writes, it just updates, and then whenever the SDK is able to commit that write, it will, and it won't duplicate it. So if you have a configuration change, you don't have to remember, did I keep that connection open or did I even write that? It already wrote. All you really have to persist is that push ID. If you persist that push ID, if you store it in a bundle and then recover it when you've come back, all you have to do is remember that something was in flight, and here was the push ID, and then you can start listening again at this location for the response. So this kind of absolves the client of having to do all of this sort of, retaining open connections and using loaders and stuff like that. I'm actually using this command response cycle in that project that I mentioned for I/O. So I'm doing it as a web app right now. I'm hoping to do it as an Android app as well, but I think this could be an interesting pattern. And again, I'm speculating. This is something I'm experimenting with. This isn't like, I'm not telling you should go out and do it like this, but if it's interesting to you, give it a shot and see if it works for you. I think that's all I have. That's what's new in Firebase. So does anyone have any questions about anything? Yeah?
Is Fabric and Firebase getting merged, or will they remain separate, especially for crash ratings and crash ratings?
Right, so the question is basically what's the deal with Fabric? So as you know, I think it was like just over a month ago, Google acquired Fabric, and so Fabric provides a suite of SDKs, kind of similar to Firebase, so it has Crashlytics, and it has digits, and it has answers, and not the what's the distribution software, Fastlane. So all of those things are going to still be operated in the short term. We're not taking those away. That said, we don't really know how Firebase and Fabric fit together just yet. Like that's going to take some time to work out. We're still trying to figure out what that looks like. But what we have decided, and I think this is fair to everyone who's already using both projects, is that we're not going to reduce the scope of offering to anyone. So everything you like about Fabric will be in whatever we offer. Everything you like about Firebase will be in whatever we offer. We're definitely not in the business of taking away functionality from people. But what that actually looks like, I don't know yet. But yeah, stay tuned. We'll have announcements about that. So. Anyone else? Yeah.
Is the robo test that you're talking about with the test lab, that seems like it's just like monkey runner and like the next chain of the evolution. Is that fair?
Not quite fair. So monkey runner is random, right? It's just it's literally just beating on your app, right? It's almost like a stress test in a sense. Robo is intelligent. It understands the widgets. So if it sees a button, it says, well, actually what it's going to do is it's going to create a view of your app and say, I know all these widgets are here, and I'm going to start descending them in the best way that I know how. So it's going for breadth, intentionally going for breadth and depth. And so if it comes, it's internally like using a graph to basically scan your app. So that's far beyond what Monkey Runner is doing. Monkey Runner is like dirt stupid, right? Robo is actually smart and getting smarter because there's logic behind it. So. Yeah.
Follow-up question on Robo. Is there any way, so a lot of applications, as you said, like they need data in order to function. Is there any way to sort of hook Robo up to like either a mock HTTP server or like some sort of hook it up to a real database that has some set of information?
So the question is, can you inject your navigation information into Robo from an outside source?
More like, how do you make sure that you're, so for example, for an espresso test, what we'll do is we'll say, pretend that the server's going to send back this information and click on these buttons and assert that the right thing's happening.
Mm-hmm.
It seems like it's more challenging to do that with Robo because I'm not sure exactly what capabilities it provides.
Yeah, so you can't really do that. You have to decide on the set of inputs at the time of execution. So it's basically a table of key value pairs, and that set of key value pairs can't really change, unfortunately. Now you could, I'm just sort of spitballing here, you could make a special version of your app that attempts to know when it's an under test by Robo and pre-fill things in order to help it along in a way that directs the test a little bit more. But that, I've never seen anyone do that yet. I'd be interested if you could do something like that and see if that worked. But, yeah. Anyone else? We have a few more minutes. Yeah.
So if I'm in like Android Studio or and use like the Firebase integration to kind of turn on some features and whatnot, or just download the like Google Services JSON file from the Firebase admin portal, like without even like turning anything on, there's already a whole bunch of like stuff in there. And so can you like talk a little bit about like what that kind of buys you and why is that already there when I haven't even turned on like FCM or anything at all?
Yeah, so it sounds like you just want to know what's the deal with Google Services, like what's all that stuff in there.
Particularly with like when I haven't even like done anything yet.
Yeah,
right?
so there's documentation for that file, and it actually outlines the structure of the JSON and how the Google Services plugin plucks values out of them and injects it into your app. And I think there's 4 main ones. It's like the application ID and like your storage bucket and your database URL and something to do with FCM. But those services are kind of like you can think of them as provisioned automatically as far as the database creation process is concerned. So even if you don't intend to use it, there's stuff back there waiting for you to use it. And if you don't use it, that's fine. If you upgrade to Blitz and you don't have a database and you don't have storage, you won't pay for anything. You only pay for what you use. But yeah, there's a lot of stuff in there. That file can get bigger, especially if you have like multiple apps defined, and so each one of those has a special ID. So you could have one Google Services JSON file that sort of feeds data into multiple apps that are attached to the same project. But again, the documentation page I think should help clear up what some of those values are. And then there's other things in there which is like that don't appear to be used at all, and you can just kind of ignore them. But I think it might be risky to get rid of them. Does that help you understand a little bit?
Yeah, definitely. Good.
Cool. Anyone else? Yeah.
So, question about SCM in particular. At my job, we're unfortunately still on GCM for push notifications. There was an error that I saw with accounts devices don't have Google accounts on them. When you register for GCM, it's like GCM registration error. Has that been fixed in SCM?
I don't know that one. My areas of expertise are mostly like crash reporting test lab, database, storage, cloud functions, and then the messaging and analytics I'm a little dodgier on. I will say that between GCM and SCM, SCM is an upgrade to GCM, and it's essentially the same on the server side. Like very little has changed. It's the same protocol that you use to send messages. The biggest changes are on the client side for FCM. The integration's easier. So it sounds like the error you're talking about is on the server side.
Yeah.
So
from my Googling around, it seemed like when you go to register your instance with GCM, whatever, if there's not a Google account device, it'll fail. So like if try caching.
yeah, well, so that's one of the things is that Firebase is distributed as part of Google Play Services, and Google Play Services requires a Google Play Services compatible device. So I would be, and essentially all the FCM messages get routed through Play Services and forwarded to your app. So if that Play Services app itself isn't configured, which means maybe it needs a Google account in order to sort of manage its presence, I can see how that might fail. But choose to find me later, either later today or tomorrow, and I can probably connect you with the person who knows that best. All right, so I think we're about out of time. I'll be here all day and tomorrow, so feel free to just grab me. I'll be wearing a Firebase shirt, I always do. So thank you very much for attending.
Thank you.